My name is Jason Hayes. I'm going to show you how to use the FaReT toolkit to non-linearly interpolate images of faces with the beta, CDF, alpha, and beta parameters. Once you have FaReT installed with MakeHuman 1.2, you can find Interpolate Render under the Render Interpolate Render menu. You can select an output directory for the renders to go to. Make sure that when you do select this directory that it is somewhere MakeHuman has permission to write to. I'm picking a Documents folder directory so that it definitely has permission. And you can see here that I'm selecting the advanced render in case I want lighting, and I'm selecting only 6 frames just for demonstrational purposes. I'm setting up the default parameters to have no rotation, and I'm picking a model file that I'm going to use for both of my start and end frames, and I'm going to start with the neutral expression, and I'm going to add the frame. So you can see it's just the first frame, and the first frame should never have the alpha beta parameters I'm about to show you. So now I'm going to go to the end frame at 1.0. I'm going to use the exact same model, but I'm going to set an expression file to a happy smile that shows teeth. And then I'm going to set the alpha and beta parameters for the mouth. So you can see that these drop-down menus for both identity, which are shape features, and the expression exist separately because they have different parameters to adjust. Select the mouth from the drop-down. It produces all of the things that will affect the mouth, lip, and tongue. I'm going to set the alpha to be really small so that everything happens at the very beginning concerning the mouth. And you can see it added with the alpha and beta values along with the parameters that it affected. If you select more things, it will add them onto the end, unless of course you select all, at which point it will go back to the regular expression for anything, $. But for this example case, we're just going to target the mouth, and then we can add our frame above. And there we go. So you've got 0 and 1.0 for the start and ending frames, and 0 of course doesn't have the parameters, while 1 retains them. And then we can go ahead and hit our render button. And this process will take a while if you have a small computer like this one, especially if you have the advanced lighting turned on. Alright, there we go. So it's at its ending point where the smile is fully loaded. So we have to take a look at some of the renders to see the results. But for comparison, I'm going to be making a linear interpolation where I've removed the alpha and beta parameters from frame 1.0, and I've updated the frame, changed my directory to render in linear instead, and we're going to let that go for a bit. Yeah, maybe I'll skip ahead just for convenience. And we're back. The render is complete, and now we can compare the images. This starting one, of course, they both look the same, with linear on the left, interpolated non-linear on the right. And if we change just one frame, there is an enormous difference already because that alpha value is so low. Going up another frame, we can see that the changes are much more subtle because the alpha value was so low. A majority of the nonlinear changes occurred in that last frame because there are so few frames. In this case, most of the changes are linear, just trying to catch up to the end result. where the jaw's going down a little bit, the eyebrows are changing, and the same thing happens in the next frame. Until, of course, finally, in the final frame, the nonlinear changes and the linear changes meet at the end result, the last frame, 1.0. In the video, let's just play all of the images in a quick succession so you can see the difference in the interpolation speeds. And there you have it. All of the images interpolated linearly on the left and non-linearly on the right, ending in the same result. I hope that you'll be able to use these non-linear transformations to make stimuli look more realistic, because not every change happens necessarily all at the same time or the same rate when a face expression is changing. Like your eyes may furrow or raise more quickly, your smile might show up a little more slow. So thanks for listening. We hope that you make good use of the toolkit we provided.